So, as I told you in the beginning, that this lecture is more related to the programming. So, we'll be working on VHDL in this module, where which is VHDL is the hardware, very high speed integrated circuit hardware descriptive language that enables modeling from gate to system level, allows various methodologies, and provides technology independence. VHDL has been standardized into VHDL different versions, so we'll be using the updated version in our aspects or our programming. Now, before going further, I want to discuss with you what we have to do in this module. This is digital design module. As I told you that we will be using VHDL to program or design different digital electronic concepts. And prerequisite for this module is digital principles. That is more of the simpler version. What we will be studying in this module, that's design, modeling, and implementation of digital systems through the use of hardware descriptive language. So it's a programming module in which we will use the hardware descriptive language, and we are designing the digital electronic circuits using the programming or this hardware descriptive language, and we will use VHDL for that. That is very high speed hardware descriptive language. So we'll be working on concepts, modeling techniques, hierarchical designs, data path control models, hardware synthesis, and so on and so forth. Microprocessor architectures from a hardware design perspective, the basic components and functionality, abstract RTL descriptions, concrete RTL descriptions, and we'll also work on the designer view versus the programmer's view, internal components like adders, subtractors, multipliers, registers. Some of them you have already done in digital principles module. So if you don't have done, or if you are joining after a long delay of your studies from the flex as a flexible student, so please go through some simple digital electronic concepts like adders and gates like AND gate, OR gate. So we will be using them. Okay, interrupts, IO controller. These are important for designing the processors. Control unit design, hardwired, micro-coded, pipelined, hard level models, HDL, modeling concepts, overview, language subsets for synthesis, design methodologies, ASM diagrams, sequence enumerations, use case models, verification, tools and techniques. So these are different modeling techniques which we will be using, and verifying our codes, and so on and so forth for different concepts like ASM diagrams, sequence enumerations, use case models, and we also be working on the system on chip, design system level, ILP blocks, soft core processors, interfaces, real world issues, PCB design issues, power reset, and DSP hardware. So, now about the learning outcomes, please go through these learning outcomes. We will be, follow these learning outcomes for our assessment strategy. And now, what the assessment strategy is there for this module? As you know, this is a 30 credit module. 30 credit module is, a double module in simple sense. So it's like that. If you see the other modules, they are 15, so 15 is written, but this is a 30 credit major module. So and it is a project based module, so there is no exam in this module. First of all, though, no midterm, no final exam. There is a group project and group presentation. So if we see the presentation that includes a hardware or software demonstration of work. So whatever you have designed, you'll be designing in the project. You need to present your work uh, here, and marking will be carried out for each student in the group. So it means you will explain your project, you will demonstrate your project, and there will be a question answer session from each student separately. So that question answer session will be carried out for each student separately, and so the marking will be separately given. Every student should know each and everything of about your project very well, and that will be used. Then we have group design report and demonstration. There can be sorry, there can be maximum of 3 students per group. So only 3 students are allowed per group. So you are required to submit a report, and there will be a presentation related to that report or project. So that will be a group project, and you will submit a report and demonstration along with the form that will the contribution form, which will explain how much you are contributing in that project. So if there are 3 students, if you have contributed 40%, so you'll write 40%. Other two, if they are so all of you should be agreed with each other. So if somebody is working major of the project, so if he thinks that he's 40% and others are agreed as well, so he will be 40%. Other two will be then 30% or 35. 30. So as the realistic marks, it's up to you how honest you are giving. Or if you think that you are equally working all of the group members, then it will be 33.33%. Or if you're 2 people together, that will be 50%. So that's how it will work. So 75% is report and project details, everything you will submit, and 25% will be the presentation. No exam or final exam, final assessment will be there in this module. Furthermore, there will be lab support available, and lectures are there as well in the labs, so that you can understand the logics. For as I will be explaining little bit of theoretical concept during Ramadan, that's why I've put it as the online lecture. But usually it will be face-to-face lecture in the college. All right. Any questions? If you have, please let me know. Fine. So if I move towards the lecture now, so far you have understood that we are dealing with VHDL in this module. We will use software known as Quartus. So you can get the copy of Quartus from the lab staff, particularly Mr. Basim and Ms. Ibtisam. Ms. Ibtisam is lecturer who's teaching also, so she will be part of this teaching team. So she will be teaching as well. Some of she's having major of the actually the digital design teaching. So now moving further to VHDL, when we are programming VHDL, there are 3 different methodologies of how we program. One is the behavioral in terms of behavior. One is data flow, how the inputs and outputs of built-in primitives are connected together, and the structural implementation, structure of the logic design. So how it is structured, so that will also be used. So these are the 3 methods. Behavioral is the functional implementation or methodology in which the system, in terms of its functionality, it is, there is no clue in that how the system is designed, but what a system has to do, that will be given from here. Apart from that, it does not contain any information about internal system structure. It describes the expected behavior. So, do you know about truth tables? Have you heard of truth table? Anybody? So, truth tables are actually all the expected values comes in. So, behavioral model is actually expression or textual version of in VHDL of the truth table. Data flow, it is in between, the behavioral and structural modeling. It's a mid ground between them. It describes how signals data flow through the logic circuits, how the inputs and outputs of built-in primitives are connected together, is expressed through the data flow modeling. The third one is the structural modeling in the VHDL. So it tells us, as I we when we were discussing the behavioral model, we were expressing that it is what system can do, but it does not tell anything about how the system can do. This structural model is how a system is composed, what components should be used, describes internal structure of system, how they should be connected, and allied to a textual version of a schematic diagram. So it's the textual version of the schematic diagram. Design flow. This is the flow chart that is explaining the whole system, what we will be doing during this semester in this module. So we will be designing, we will be writing the code in VHDL. The code will be the design, the circuit. All right. So in the programming, we will be writing the code, and it will be synthesized, debug, functional simulation is done. If the design is fine according to the requirements, then it goes to the place and routing fitting, and we will check its timing simulations. Timing is very important when you're designing the hardware. uh, why it is important? Because you need no delay when you are clicking some application. It should come up according to the requirement. So whatever, as a designer, you are putting the delay into time, or the timing requirement, how fast your system should be, or how slow your system can be, that if it is met, it's fine. If it is not met, you will redo all the working. If it is fine, then you will put this code, or upload this code onto the FPGA board. FPGA board is the device that is known as the field programmable gate array, which is used to run this code as a hardware. Okay, so that we will be working through. So hopefully in the lab session, you will work out on the FPGA boards of the codes which we will be working in the classes. The VHDL program, usually we call it as a system. A system is regarded as a body, an interface, and some additional add-ons are there. VHDL describes uh, using three sections of an entity, an architecture, and packages. So it's like a C program. What we have in C program, we have the libraries which we include as hash include stdlib.h or stdio.h, stdconio.h. So these are different libraries, and then we have main file, and in the main file we define some inputs and outputs, and then we write down the algorithm to implement that. So here we don't do in the same way, but we have, instead of number include, we have packages, add-ons in the beginning, same as what we are doing in C. However, instead of main function, we have two parts. One is the entity where we define our inputs and outputs, so it's the interface. Along with that, we have the architecture, the body, the algorithm of the code. The interface, or the entity of the system. uh, a system communicates via an interface. Interface is entity in VHDL. Cannot have any VHDL system without an entity. So every program should have an entity in VHDL. Just like in C, again I'm coming because I hope you guys have done the programming module, and C is the basic one, C++, C, where we write any program without main function cannot be implemented. So there should be a main function. Here we should have an entity in the VHDL program. So there cannot be any VHDL system or program without an entity. The body of the system is that accomplishes some task, or that is the algorithm, that is is the architecture. In C++, the entity and architecture both comes into the main function, but here we have architecture as separate. And here we are designing the hardware using this programming. So in VHDL, the body is called the architecture, and architecture, for instance, we are defining. So these, the yellow words are the keywords of VHDL, and the white ones are the ones which are labeled to these architectures. So you can use anything of this architecture, my architecture. So the name of the architecture of my entity, which was the name of entity given, and is begin. It begins and then end architecture. So this is the syntax of architecture. External source of description allow you to define items outside of VHDL standards must be declared in advance using library. These are the packages, the library, and use keyword usually before entity. This is the first program that I wanted you to see it. So this program is having three parts: the library, which we call packages, we have interface, that's the entity, and we have architecture, the algorithm, or the method of implementation. As I told you that there are three methods for implementation of the VHDL codes. What are those? One is the behavioral model, second one data flow, and the third one the structural modeling. So we will be using all these. So one of them, or sometimes maybe in our project, maybe two to three of these at different stages we will be using. So this one is the first code where we are using the structural model, in which we are using and not exclusive or gates. So this is the standard library we will usually be using into our code. So usually this library will be there in every bit of code which we will be using. So library IEEE use. So there will be a comma here. Use I from the IEEE library, use this book, for instance, IEEE.std underscore logic underscore 1164 dot all. So we are using the input outputs of std logic of this library IEEE. Now the entity as it is the interface, the black box of the system, which shows the interfaces, the ports, the inputs and outputs of the system. So, if we are designing entity which is the lift system, so it is a lift system for which we are designing the hardware. So we have the library, we have already put it entity, we have given the name as lift. Entity and is are the keywords as we discussed earlier, and lift is the entity name which we have given to it. Port BSRC in STD logic. So these are the inputs B, S, R, and C, and D is the output. So that's out STD logic. In STD logic, out STD logic. So these are it is the port and we end lift. So only we define in entity we only define the inputs and outputs or the ports of the system. The architecture. As I told you, architecture is the methodology. Architecture gates of lift is so architecture gates. So we have given the name of the architecture is the gates of lift, the entity name. This architecture is written for this entity lift. So lift is so your system will understand that lift is, and then signal AE is STD logic. This is the input output signal which is in between, which is not a port but it is a wired signal which we will discuss in a while after this program. So this is the assignment operator. So A is getting the value of this expression, that's input is B and not S. So B and S both are, you can see, are the inputs getting the values from the user. B and not of S. So it's not of S ended with B will give us the value of A. Similarly, E is not of R exclusive or C. So R exclusive or C. You know exclusive or anybody? Do you know about AND gate? I need answers. It means that
Yes, Mr.
yes. So this is effort for you guys. But if you are sleeping, then how can I? We need to be active with each other. If I am talking, I need something from you. Ask questions. Make my life difficult so that I should be preparing more for you guys and get some uh, uh, you know uh, good concepts out of it, and we can have a very good lecturing here. Okay, so exclusive OR is a complex gate which is combination of and or and NOT gate. So that is A bar B. A bar means not of A, B, plus plus is OR. So these are the Boolean expressions for exclusive OR, and then uh, A B bar. So A ended with not of B. So all of this result comes to be the exclusive OR. Here, this is the exclusive OR between R and C. We not it and we get it as E. A and E, because both are used again, so that's why they are signals. So whatever we assign them the value, it they are ended together and we get value into D. So that's AND gates. So that's the architecture for GAT. In Quartus, if we write this code in Quartus, so that will be like this. Afterwards, when we run it, we get its timing waveform. So timing waveform is like this one. So we have a timing waveform where we give values and we get it. So we have, using truth table, signal name is statement, and so we have, when we use the truth table, so we can have the similar implementation with same entity, but different architecture. Here the methodology used is behavioral model, where we use process statement, and so something like truth table again. So this is like a truth table of four values which are concatenated together and we used. So same waveform comes out. So there is no difference between structural and behavioral model. However, when we see the synthesis schematic diagram, we have very clearly exclusive or connected with AND gate. With these bubbles represent the NOT gate, and we get the output. Here in the behavioral model, we get a multiplexer out of it. So it's from the system. So we don't know what is in the box. So it's a black box, but it is the algorithm is used and finds out what the value of D is. Now, whatever we have used, so in during upcoming weeks as well, we will be working on different VHDL concepts only. Okay, and after the ETH, when you will be will have a bigger class, more time. So there we will be using those concepts, using these lectures to implement different type of sophisticated digital circuits. So it's better for you guys to attend those, and I will try to be hybrid as well during that time if possible. If not, there will be the recorded lectures available on the book. So what is a port which we used in the entity? A port is a channel for dynamic communications between a block and the environment. The syntax of port is port declaration. Ports are mainly used in entities and components. Five available ports in VHDL. However, we only consider three out of them, which is in, out, and in out. So in is for input port, out is for an output port, and in out is a bidirectional port. A port could be a single line or it can be a vector, a bus. So if we have a single line, then it is in std logic, and if it's a bus or a vector, then our uh, prototype, our keyword is std underscore logic underscore vector 3 down to 0. It means 3 2 1 0. So it's a 4-bit vector we are defining as a 4-bit input vector or input bus, and D out std logic, again a single line or a wire. In terms A, B, and D are single lines or wires. A, B are the input and D is the output. Now there was another term that was signal. Signal is an internal channel for dynamic communications between different parts of logic design. The syntax for of a signal is signal, signal names, and signal type. So it's different from port, but it is because it is not the input and output of the interface, but it is uh, within the system it is used up, so that's why it is a signal. Signal could be single line and it can also be vector, same as port. So it's std logic vector 2 down to 0. There was another thing in the behavioral description, that was the process statements. Behavioral descriptions are supported with the process statements. The syntax of a process is process, sensitivity list, and begin end process. The process statements can appear in the body of an architectural declaration. So this was the an introduction so far for our VHDL concepts, and afterwards, any questions so far you have? If no, then I will be moving to our first part of the VHDL. So far we have introduced what VHDL is, and we have gone through a simple program of VHDL. So I recommend you to install Quartus in your laptops and working onto this first program by yourself in the VHDL using the Quartus software, so that you have better understanding of the language. I'm opening the same one. Sorry for that. So let me open the correct one. Yes. Just a minute, I think. Let me just a minute, please. Yes, guys. Any questions so far in this VHDL? Because I want here you to go through one of the this VHDL program. So, have you installed VHDL? Have you got the software or from the college?
No, Mr. Not yet.
So when will you get the software? It is from with Mr. Basim. He can give you, or I will try to arrange it on Moodle. Let me take some space on Moodle because it's a software, so it may take. I will share with you guys on Moodle, but sometimes you need to visit the college. Let me.
It's better to keep it in the module.
Yeah,
Then
yeah,
you
yeah.
can
Obviously,
download it.
we will be keeping it in the Moodle, and it is a project, so you need to work on this programming, in using this. Okay, so the next part of VHDL, I don't want to burdenize you everything together. Usually, when you implement, it takes time. That's why. So I will try to put the Quarter software and its installation methodology on the Moodle, and then you can install it. And please work out this. And I will also share these slides on the Moodle with the recording, so that you can implement it and put it on and work it out through that. All right. Any
Nice.
questions?
Thank you.
Thank you, Chief.
Thanks a lot. So see you inshallah next week.
Master,
Yes, brother Ali.
this time for the all groups.
Yes, actually, I have put, because my groups are 10:30 and 12, but this is only for Ramadan, for 2 more weeks.
Only
After-
because
yeah,
today, because
Yeah,
tomorrow we have class with you.
yeah. So if you have class, the lab is, I think, so far will be in the college. So I will ask Basim if he can give you some online, but it is difficult, online. Talking theoretical things is fine, but programming, you need to be on the systems. You
Yeah.
need to be on computers. So that's why for lab you need to come to the college, or we will put you that there will be recordings available. All right.
So will be one class online every week.
Yes.
Okay,
So
thank
that's
you.
also to support. Here the class is going on, but I'm recording only particularly to give extra support for you guys.
Okay,
Okay.
thank
Thank you very
Mr.
much.
Okay.
Yes, brother.
Yes, regarding this group work,
Yes.
we are in group 4, I think. So we can make a group from someone from group 1, someone from group 2, like that.
Any enrolled people in the module, you can make a group. No problem.
Okay.
So we will share with you the list, so you can make group anywhere. But the group maximum members in the group is 3, not more
Maximum
than
3. Okay.
2 to 3. Okay. So thank you very much. Best of luck.
thank you.
Hopefully you'll have a great time, and pray for me, pray for yourself during Ramadan, for every Muslim. Have a good time. Assalamu alaikum.
Okay, all right.
Thank you, Mr.